Hello, I'm Alex, a Principal Solutions Architect at ElastiFlow. In today's video, we're going to configure a network device to send flows to our newly installed Elastiflow Flow Collector. We're then going to configure our Flow Collector to connect to Elasticsearch. And finally, we're going to visualize the flows in Elasticsearch via Kibana. This is the demo environment we're going to be using today. We're going to be configuring NetFlow on R8. More specifically, we're going to be configuring NetFlow on Ethernet 00 and Ethernet 10. The first thing I'm going to do is type enable, and the next thing I'm going to do is type config t. Configuring NetFlow on a Cisco device is really just 4 easy steps. The first step is we configure the flow record. This specifies what data we will match and collect on. The second step is we configure the flow exporter. This is our flow collector. It's where the flow records will be sent and on what port. The next step is configuring the flow monitor. This is what we will apply to the individual interfaces. In this case, I'm also going to configure the cache active and inactive timeout values. We'll go into detail about that later. The final thing we need to configure is applying the monitor to an interface. As you can see, I'm applying the flow monitor to Ethernet 00 and Ethernet 10 on router 8. I'm also applying the monitor in the input direction, which means I should see all traffic coming into that interface. And here you can see the final completed NetFlow configuration on R8. The flow record, the flow exporter, and the flow monitor. And here we've configured the flow exporter to send the flow records to our ElastiFlow Flow Collector at 192.168.0.205 on UDP port 9995. Now that we have a flow exporter sending NetFlow to our flow collector, we're going to edit our flow collector's configuration file and enable the monitor output. This is a very basic output. Its sole purpose is to print a log message with the current flow rate. As you can see, I'm configuring mine to monitor enable true with an interval of 5 seconds. I'm then going to run systemctl daemon reload and systemctl restart flow call. Once we're done with that, we can go back to our flow collector and verify that now we are seeing flows via the monitor output. Now that we're seeing flows and everything appears to be working, we will enable an output. In this case, I'm going to enable Elasticsearch. We're going to enable the bare minimum of settings required to get Elasticsearch configured as an output. The first setting here enables Elasticsearch as an output. The second setting enables ECS, which is Elastic Common Schema. We have pre-built Kibana dashboards that come with ElastiFlow, and depending on how you configure this setting, will determine which files you import into Kibana. If you enable ECS, for instance, you will have to import the latest ECS ND-JSON Kibana dashboards. If you leave this setting set as false, then you'll have to import the ND-JSON codecs files. Since I am not enabling ECS, I will import the codecs ND-JSON file into Kibana. We're not going to configure the next few settings, but batch deadline is the maximum time in milliseconds to wait for a batch of records to fill before being sent to Elasticsearch via bulk API. Batch max bytes is the maximum size in bytes for a batch of records being sent to Elasticsearch. Timestamp source is the timestamp that will be used for the @timestamp field. Usually end or collect will be the best settings here. Index period allows you to specify how often new indices will be created. This will also be used to enable rollover and ILM. I'll be enabling rollover and configuring ILM, so I will set this to rollover. Elasticsearch index suffix can be used to add a suffix to your indices. Enabling index template specifies whether the output should add the required index templates to Elasticsearch. We will enable this, which will automatically install the index templates for us. Overwrite will overwrite the templates if they already exist. Template shards specify the number of shards with which the index should be created. As a general rule, additional shards can increase ingest performance, assuming there are sufficient data nodes, and replicas specify the number of replica shards. Index template refresh interval specifies the period for the refresh interval. The refresh interval is the time window in which newly ingested documents are added to a segment, prior to the segment being added to the index. Only after the refresh interval has ended and the segment has been added to the index do the documents become searchable. Index template codec specifies the level of compression used for stored values. The next setting we will change is the output Elasticsearch addresses. This setting specifies the Elasticsearch servers to which the output should connect. It is a comma-separated list of Elasticsearch nodes, including port numbers. We will configure our single Elasticsearch node here. We'll add a username, a password, we'll enable TLS, and we'll set skip verification of TLS to true. In a production environment, you would add your cert path here. Now that we are done, and because we modified environment variables, we will run systemctl daemon reload, followed by systemctl restart flow call, and then we'll verify the flow collector is connecting successfully to Elasticsearch. Now that the flow collector is connected to Elasticsearch, we will verify that we have data coming into Elasticsearch by logging into Kibana and going to Stack Management and then Index Management and verifying that we have an index with documents. Now that we have data, we're going to import the appropriate ElastiFlow dashboards into Kibana. In order to import the dashboards into Kibana, we'll need to go to Stack Management, then Saved Objects. We'll then click the Import button. We'll click the Import button a second time, and then we'll select the nd.json dashboard file for whichever setting we configured in the ElastiFlow Flow Collector earlier. As I had mentioned earlier, if you enable ECS, you'll have to import the ECS dashboard file. Since I did not enable ECS, I will import the codecs file. I will also import the advanced settings for my cluster. Now if I click on the menu button and go to Dashboards and search for Types, I can click on one of the ElastiFlow dashboards. Great! It looks like data is coming into Elasticsearch and we can see it in our ElastiFlow dashboards. You might be thinking, well, IP addresses are useful, but I want to see host names. What we'll do now is enable DNS enrichment. To enable DNS enrichment, what you'll need to do is find the flow call configuration file and edit it. You'll need to find the IP address DNS enable configuration line and set it from false to true. In my case, I'm going to configure a DNS server, but if you don't configure a DNS server, it will use whatever the host OS has configured already. I'm going to configure my DNS name server timeout value to 500. This value is in milliseconds. And that's it. I'm going to save the file, run systemctl daemon reload, systemctl restart flow call. I'm going to go back into Kibana and look at the newest data. It looks like I now have DNS names instead of just IP addresses. So let's go ahead and generate some data and visualize it in Kibana. I'm going to click on this Windows 10 box here. We're going to go to speedtest.net and I'm going to start a speed test. You might be thinking, but it only shows 20 megabits per second, and your speed test clearly says it's going at 100 megabits per second or more. That is because the windowing here is per minute. So what you're looking at is a 60-second average of the total throughput. One of the many advantages to using ElastiFlow is the ability to customize any and every visualization. Remember earlier when I configured the cache inactive and active timers to 1? Well, because I did that, now I can configure the interval inside of the client's throughput visualization to 5 seconds. I'm able to visualize the traffic down to 5 seconds of resolution. Now you can see what actually happened during the speed test. You've probably never looked at a speed test like this before. With this level of detail, you can actually see it opened up 4 separate connections to 4 separate servers for this one download speed test, with each connection achieving between 20 to 40 megabits per second. In aggregate, you can see we achieved 128.6 megabits per second. I'm sure this left you with a lot more questions since I can't really go into detail about every use case in this one video. We will make more videos in the future highlighting use cases from customers and things that we find. But if you want help, if you have questions, or if you just want to come hang out, please join us in our community Slack channel. You can get to it by going to our main website, elastiflow.com, clicking on Get Started, scroll down to the Join Our Slack community, and then click on the Join the Conversation button. Thanks for watching this video, and I'll see you in Slack.